Hello everyone, welcome to this video lesson. In this video lesson, we would like to find out effective Young's modulus of two different wires connected in series. Let me tell you what's the meaning of this. Assume there is a rigid support to which one wire is connected, which is made up of a material whose Young's modulus is Y1, having a certain length L1, for simplicity's sake, assuming like area of cross section is same for two different wires A. Now let us connect it to another different wire. It's in fact a thin wire. Just for the sake of a diagram, I am showing a little thicker wire. This is another wire. This is made up of a different material, so its Young's modulus is different. Let's assume its length is also different, but area of cross section is same. Now I want to calculate what is the effective Young's modulus of this combination itself. This kind of a connection is called something like a series connection, one after the other. Let's assume we have applied some force here at the bottom of the lower wire. One thing that we need to know is the force first acts on lower wire and then it go and act on the upper wire because you are applying it on the lower wire. But the entire force first acts on the lower wire and then acts on the upper wire. I mean to tell you the force acting on the first wire equal to the force acting on the second wire. The force is going to be the same. The lengths are different, L1 and L2. And Young's modulus are also different, Y1 and Y2. Thus, even as the force is same because the lengths and Young's modulus are different, delta L is different for both the wires. I would like to say the total elongation in the wire, two wires together, delta L total, could be identified as increase in the length of the first wire as well as increase in the length of the second wire. How can we get this delta L? Basing on the definition of Young's modulus itself. Let's remind ourselves what is Young's modulus is. It's a ratio of longitudinal stress by longitudinal strain. Rearranging the terms, force into length, area into delta L. So we can write the equation for the delta L as FL by AY. Now, using this formula, delta L total means F total, L total by A total and Y total. Delta L is having a formula like that now. Get the Y this side equal to F1, L1, A1, Y1, F2, L2, A2, Y2. I am simply using this formula and substituting the data that is available for us. But we know the F total, that's a total force acting on the system, is the force acting on the first one as well as the force acting on the second one. L total, because they are connected one after the other, the total length is equal to L1 plus A2, L2. The area total is A itself because A1 equal to A2 and they were connected one after the other. If you connect the things in series, length increases but the area remains constant. See here, the total length is L1 plus L2. Because of this kind of a connection, the thickness remains the same. Area remains the same, so the thickness remains the same. So putting this data in this equation, we can get F total as F itself, L total as L1 plus L2, A total as A, Y total, let me call it like Y series in this equation. Now in this equation again, F1 is F, L1 is L1, area is A, Y1, and again F, L2, area, and Y2. So it's very clear that I can cancel these F's, I can cancel these areas also. So what's remaining? L1 plus L2 by Y series equal to L1 by Y1 plus L2 by Y2. Of course, we can simplify this equation further and find out an effective Young's modulus. But I would like to put a condition here just to simplify it. If two wires are initially having same lengths, just to simplify this case further, that is L1 equal to L2 equal to L, then this equation will change further. This equation will change further. How it change? L1 is L, L2 is also L, Y series. L1 is L, Y1, L2 is L, Y2. Then 2L by Y series equal to L by Y1, L by Y2. Else can be cancelled. Then 2 by Y series equal to 1 by Y1 plus 1 by Y2, that is Y1, Y2, Y1 plus Y2. So Y series equal to 2Y1, Y2 by Y1 plus Y2. But be careful, I can use this formula in a certain condition. What is that certain conditions are? The two wires has to be in series. They shall be having the area of cross section same, lengths also same. In that case only I have to use this formula. If the lengths are different, I can simply use this formula and get the effective Young's modulus itself. That's it. Thank you for watching. Keep coming back for more and more video lessons. Thank you.